organization
this meeting is being recorded
this evening. And we have the pleasure to welcome Abdul, who is specially dialed in from Dubai, as I understand, Abdul.
So, yeah, correct.
Yeah. And you will talking about Ceph Cluster, and you have the claim that you can set one up in 1 hour. That's very interesting. And if I may already pose a question, what is the actual, you hear so many different numbers. What is the actual minimal production size cluster, Ceph cluster? How many nodes? So look forward to your story. Abdul, take it away.
Yeah, sure. Thank you. So I will start off with the up and running Ceph cluster in 1 hour. We will be discussing today how to deploy a Ceph cluster really within an hour, and we will see it can be deployed within an hour. It's a kind of myth that it takes a lot of time, but if you prepare it well before starting the deployment, it can be deployed in less than 1 hour. So we will see how we can do that. Okay. So starting off, something about me, I'm a Red Hat certified architect. I have quite extensive experience working with cloud and storage solutions. I started working with OpenStack back in 2015. So currently I work as a solution architect at NEC Corporation here in Dubai. So the teaching is my passion. If you know Sander, so Sander reached out to me on LinkedIn and he convinced me for this tech talk. So I'm here so delivering this tech talk. So
thank you for that.
Yeah. So something about agenda. So what to expect from today's tech talk. So first we will talk about Ceph Storage Architecture. What are the components which make Ceph Storage Architecture, and then we will see what are the factors which should be considered before deploying and designing and deploying Ceph Storage. So the next thing we will see how we can actually deploy a Ceph Storage using Ceph Ansible. And last, we will see how to operate a running Ceph Storage cluster. So if you guys have any questions in the meantime, just raise your hand or you can interrupt me and I would be happy to answer. So starting off with why Ceph. So Ceph delivers object, block, and file storage in one unified system. So now I see some other storage vendors have also started this, but this was a unique aspect of Ceph Storage for a long time, that it delivers object, block, and file storage in one system. Normally, the storage servers or storage solutions we have were mostly providing either block storage, and then for object storage, we still face some issues with some proprietary storage solutions. But normally with Ceph, since it's an open source, so we have quite a lot of flexibility in this. And then obviously it is reliable and free. The main selling point of this storage solution is it's free, is it's open source, and if you know it well, it is easy to manage. And this thing is very important to know, that if you understand how it works, and you need to understand how it works, then you can easily manage it. So what are the use cases? I mean, you can use Ceph with OpenStack, you can use Ceph with Kubernetes backend. I mean, for the object storage part of this Ceph storage solution, you can connect it to Kubernetes, and then OpenShift as well. I mean, Red Hat mostly sells this Red Hat OpenShift with Ceph storage as a backend, and then some other open source use cases like Proxmox and some others as well. So how it actually works on a high level. So we have one storage solution, Ceph cluster, which is, you can consider as a RADOS, reliable autonomous distributed object store. And let's say we have one object storage available on a Ceph cluster. So what you can do is, what client will do is, it will some application will request to store an object. It will come to RADOS gateway. It is the part of Ceph Storage Cluster. It will be one of the nodes in Ceph Storage Cluster which will be handling this request. And then the next thing will be, it will come to librados. It is basically a library to interact with the low level, you can say, the actual disks or the storage solution itself. So whenever you send a request for storing an object, it will first come to Redis gateway, and then it will interact to libredis, and it will eventually be written onto this disk using Redis. So we will see what Redis is, and then crush maps and what are the details. So I'm just trying to explain it on a high level for now. So similarly for the block storage, we have normally block storage is used for the operating system level storage. So for the block storage, we have RBD, Redis block device. And what happens is basically an OS connects to this RBD. Some people also call it remote block device, but normally it's Redis block device. So OS actually connects it to Redis, and it then interacts with libredis, and eventually it reads and writes data on the Ceph cluster or the Ceph storage nodes. So, and then one more point we have for a file system as well. So file system is similar to what NFS is. So Ceph provides NFS. Okay, I mean NFS level capabilities, and then what we can do is basically we can connect any client to this Ceph file system, and then it will eventually interact with libredis and Redis to read and write the data. So this is on a very high level. I know you some of you might not be familiar with this Redis gateway RBD Ceph file system. So as we move along in this, I will try to explain them. So this will eventually make sense to you. Okay, so what are the components that make Ceph storage? So we have some Ceph storage components or daemons which are running, and each daemon has its own purpose. So we have a Cephmon, Ceph OSD daemon, Ceph manager, MGR normally called, and Ceph metadata servers. So we will see in a little bit detail what exactly is the purpose of this and how actually these are combined to make a one full-fledged Ceph storage solution. But before we go to them, we just on a high level, we'll understand what are the crush maps. So basically Ceph uses an algorithm for storing the data, and that algorithm is called crush. So what crush exactly do is basically it determines how to store and retrieve data by computing storage locations. And what we mean by computing storage locations, it basically calculates it first creates a cluster map. It creates a physical, I mean it creates a map of all the physical OSDs, all the physical storages in storage devices installed in the cluster, available in the cluster, and it creates a map. And based on that map, it performs the calculation. So let's say we need to write a one object. So once the request comes to Ceph storage cluster to write as any object, in the backend crush algorithm works. And crush algorithm, what it does is basically it calculates which disk exactly the data is going to write. Let's say we have three storage servers, and we have, let's say, around 36 storage disks available on those. So this crush exactly calculates where to store that data. So with an algorithmically determined method of storing and retrieving data, Ceph avoids a single point of failure. So if you have a little bit experience with some proprietary storage solutions, so what happens is in those storage solutions, there is one storage controller and the other is disk shelves. So if the controller fails, and there is, I mean, normally those are deployed in quantity of 2 and high availability. But let's say if one controller fails, the other controller takes up. But here there is no concept of that controllers. Each Ceph storage nodes works independently, and it stores data independently regardless. There is no specific controller for that. Each Ceph storage server can compute its own I mean, it runs its own algorithm and it computes how it can store the data. So on a high level, this is how crush works, and this is what it does. Crush basically stands for controlled application under scalable hashing. So we will see a little bit in more detail what are the benefits of this crush and what exactly it does in case of OSD failure or the disk failure specifically. Any questions till now? I think Gabor, you are on mute. Okay, so what are monitors or Cephmons? So basically, Cephmons maintain the map of the cluster. And what we mean by map of the cluster is basically, let's say we have storage nodes, a total of 3 storage nodes, and then we have 3 other nodes called Mon and MGR. So Mon will have a full detail of all the storage disks available. Let's say we have, consider very simple, we have 3 storage disks per server, so it will become 9, and from those 9 disks we have, let's say, 100 GB per disk, so it will become simply 900 GBs in total. And then we will have some replication factor. Let's say we have a replication factor of 3. So what we mean by replication factor of 3 is basically a single object which is written onto that disk, it will be replicated thrice, 3 times on 3 different disks. So if one disk fails, so that object will still be available, and that third disk from the disk from which object, or the disk became the disk which became down on which that object is stored, it will be moved to another disk. So this all happens in the background. You can say the crush calculates this. So a Cephmon maintains the map of cluster state, including the monitor map, manager map, OSD map, MDS map, and crush map. So monitor map is basically how many monitor nodes are there. Monitor nodes are basically for you can say in simple terms, the monitoring kind of solution in which you monitor all the you can storage servers running in that. And then we have a manager map, so we will see in detail what is the manager and what exactly it's calculate. But whatever that MGR node calculates, it forwards that to Mon as well. So Mon is our single point of interaction where we can, from where we can get all the information about the cluster. But the overall functions are divided into different small, you can say, daemons or small set sub servers. Like we can have one Mon server, one MGR server, each performing its own functionality. So then we have an OSD map. As I said, OSD map is basically, OSD stands for object storage device, and there's that you can simply consider a storage server on which disks are available and you store the data. And MDS stands for metadata server, and MDS is for Ceph file server for NFS. So NFS backend runs normally on MDS map. And then crush map is basically the physical, you can say, the map of physical infrastructure or physical storage solution deployed. So these maps are critical cluster state required for Ceph daemons to coordinate with each other. So basically, if one Ceph OSD goes down, Cephmon will know that, and based on that, it will perform new calculations to move the object from failed OSD to others. And also, if new OSDs are added, so it will perform recalculation for some things called pools and placement groups. So these are the things which Mon normally performs. And then it also performs, it also manages the authentication between daemons and clients. So let's say we have a Ceph client. Let's say we have an OpenStack working as a client, which is integrated with our Ceph storage. So what will happen is basically it will interact through Mon. Mon will then forward their request to MGR or OSD based on what exactly is the request. So normally 3 monitors are required for redundancy and high availability, and you know the concept of quorum. So that is what this Mon follows exactly. Okay, so next we have OSDs. This, to put it very simply, these OSDs are basically the storage servers on which data is actually stored. On Mon, data is not stored. Mon is just for monitoring purposes. These OSDs are actual servers on which data is replicated and stored. So Ceph OSD stores data, handles data replication, recovery. So recovery in case of, let's say, if some OSDs goes down, we have 3 OSDs on one server. So if one of it goes down, so it will perform recovery and rebalancing. So OSD is down now, that is not part of the overall storage cluster. So it will perform recovery and rebalancing. And also it forwards the information to Ceph monitors and MGRs. So if one server have multiple OSDs, it will calculate the information and forward to Mon server and MGRs based on the request. So at least 3 Ceph OSDs are normally required for redundancy and high availability. And why we required 3 is basically I think since you guys are already familiar, most of you will be familiar with Linux. So normally 3 is the concept to avoid split brain and to maintain quorum. Similar to this, it will happen in OSDs as well. So let's say we have 3 OSDs on one server, and we have total of 3 servers. So in this way, we can at least maintain some high availability and redundancy. Otherwise, if we have 2 disks on one server and 3 on the other, then we will not be equally able to divide the data between different servers. The next is basically we have MGR, and what MGR does is responsible for the runtime metrics, and we will see one Ceph dashboard in which actually these metrics are available. So see, this MGR keeps track of metrics and current state of Ceph cluster. So if any OSDs goes down, any server goes down, uh, it informs the monitor node, and also it shows us the overall storage utilization, what are the current performance metrics and system loads. Let's say if any of the pool or any of the storage disk is getting utilized in some overall storage utilization of the cluster is above 50% or 80%. So MGR will raise an alarm based on the configurations we provide. So it also runs the manager daemons Python-based modules to manage and expose Ceph cluster information. So as I said, that MGR is running Ceph dashboard and REST API. So these things are normally run through Python. So that is why it is running some Python-based modules. Okay, the last one. So MDS, MDS is also called metadata server. So metadata server is basically to run the Ceph file system, and Ceph file system is basically a file system or a backend server to run NFS on client servers. So it allows a POSIX file system users to execute basic commands. So basically you will connect to it like an NFS server, NFS client, and you will have all the same functionality which you get using some other NFS server. So using this Ceph instead of that typical NFS server, it provides a lot of redundancy extra functionality which normal NFS servers don't provide. So how exactly Ceph stores data? So basically we have one client which sends a request. So there is a concept in.
Can I ask a question about the quorum? You were talking about that for the OSD you need at least 3. Is that the same for the metadata server and for the manager? And
no. Okay. So for manager, at least 2 are required, because the way Ceph works is one manager is active at a time at maximum, and the second is standby. For MDS, it depends on the usage. So we will see how exactly these are configured or deployed. So normally MDS is actually a server which is handling only the requests. The actual data is still stored on the backend OSDs.
Mm-hmm.
So if we configure it correctly, we need to have more than one MDS, obviously, to maintain high availability.
Exactly.
But it depends on what level of high availability is needed.
But so they don't have a quorum protocol. It's just one hot standby or something.
Yes, correct. Okay. We can deploy one only as well.
Okay, thank you.
Okay, so in how exactly Ceph stores data, basically we have concept in Ceph called pool, PG, placement groups, and then OSD. So pool is a way of you can say segregating the Ceph storage backend. And how exactly we segregate is basically we create one pool. Let's say we create one pool called OpenStack class or OpenStack backend. Okay, and then we assign some policies specific to that. That pool will still be using all the OSDs in the backend. So in if you see in the diagram, let's say we have 5 OSDs. So if we create 3 pools, all these 3 pools will be writing on these 5 OSDs randomly based on the crush algorithm calculation. But we can set some policies on this pool. Let's say we can, and we will see how we can set those policies, or how can we manage pools separately. So pool, let's say we created one pool for OpenStack, and then we use that pool to store, let's say, Cinder volumes in the backend, or some block volumes in the backend. So we configure OpenStack replication factor to be 3. So since those volumes or those block storage is critical, so we configure that that pool to be critical, and we configure replication factor of 3. Then we have another pool 2, which is for some other non-critical application, and we make it replication factor of 2. So for this OpenStack pool, the one object or one type of data will be replicated to 3 devices. The other, since it's not non-critical, we make the replication factor of 2. It will also write on the same disks, but the replication factor will be 2. Thus 2 copies of data will be stored. And similarly for other pools, we can have some different policies. And it is not only about this replication factor. We have several other factors which are important and which are to be considered for each kind of application. It depends on the application needs. So what are the placement groups? Placement group is basically, we have one pool which interact with placement group, and placement group actually stores data on the OSD. So let's say we have a Ceph client which takes an object and write it to a Ceph pool. Okay, and then once the request comes to Ceph cluster, Crush assigns an object to a placement group. So each object is assigned to a specific placement group, and then that placement group, and then Crush assigns a placement group to an OSD. Okay, so an object is written on pool, then the pool request Crush assigns that object to a placement group, and then that placement group is assigned to a specific OSD. Okay, and then if the replication factor is 3, so the data should be written to 3, all of the 3 at the same time. So what exactly happens is data get written to primary OSD, and that primary OSD replicates the placement group to secondary OSDs. So normally, on a high level, in a very basic way, this is how Ceph stores data in the backend. And one more thing to consider, since it was always a topic of discussion for Ceph, that Ceph does not provide high IOPS. So if you consider a version before Luminous, there was some issues. I won't say issues, but in terms of performance bottleneck, there were some limitations. But those limitations are mostly, I would say, fixed by using BlueStore. So earlier, Ceph used a backend called file store, and now there is a new backend called BlueStore. So the difference between them on a very high level is, that file store uses XFS in the backend. So XFS is a full-fledged separate file system. So there is a Ceph cluster running, it performs its own calculation, everything, and then there is a journaling file system for XFS, and then any object which gets written to the XFS, first it comes to the file store, it comes to the object map, level DB, and then XFS. So the writing data to the storage backend was a bit slower because of all those calculations to be made before writing data actually on the hard disk. So for a BlueStore, I would say a simple term which some of you might be aware, it is similar to what we call SRIOV DPDK. So what happens in BlueStore is basically there is no layer of the actual file system like XFS in BlueStore. What happens is BlueStore is directly interacting with the storage backends or storage hardware, either it's HDD or SSD. There is RocksDB and Blue file system, which is a minimal file system used for just interacting with the you can say, because BlueFS is running is user space, so that BlueFS is interacting with backend hardware directly. And that is how its performance got improved. I mean, on a very high level, this is how it got improved. And now it can provide a lot of high IOPS, which were not achievable using Ceph file store. So after starting Ceph Luminous, the Ceph backend is changed from file store to Blue Store. Any questions till now? Yeah, okay.
Oh, we are good. So
Okay. So the next is basically what are the factors which should be considered before deploying Ceph storage. So as I mentioned, Ceph can be deployed on any commodity hardware. It is not a proprietary solution to be deployed on any of the specific hardware. Let's say we can deploy, I mean, we even have one cluster mix of Dell and Cisco servers. So we have some Dell servers with some specific configuration and Cisco servers with some specific configuration. I have mentioned some point next using dissimilar hardware, but that dissimilar hardware is basically you have, let's say, one server with, let's say, 64 GB RAM and two socket processor of, let's say, 16 cores in total, 8 socket one, and the other comes with also 8 sockets. So that 16 socket processor, 64 GB RAM, and then you have 3 OSDs with, let's say, 1 terabyte each. And then the other server, you have 5 OSDs with, let's say, 2 terabyte each, and that server is having 256 GB of RAM. So that is the dissimilar hardware exactly which I have mentioned. The in terms of just brand name between Dell and Ceph, it is not. I mean, we cannot say exactly that these are dissimilar, because if the configuration actually matches, there can be slight performance differences because both are from different, you can say, vendors. But if the actual hardware configuration is same, then we cannot say that those are dissimilar. So normally what I was mentioning is Ceph can be deployed on any hardware, so it becomes easier to select any of the available hardware which matches our budget. So basically Ceph is used for high performance applications, but it also provides benefit of like cost saving, even and especially if we go with the free version of or the community version. So when planning out your cluster hardware, you'll need to balance number of considerations, including failure domains and potential performance issues. So failure domain, we will see in next slide. So two most important issues. One, I mentioned dissimilar hardware, and what we mean is basically the hardware configuration within the same cluster should be same. Otherwise, the pool which you are going to create should be created in a way that, let's say, you have 6 Dell servers in that Ceph storage cluster and 4 or 5 Cisco servers. So you create a pool in a way that you segregate, or you use 6 servers from Dell for one purpose and second for other purpose. You should not be using, let's say, for OpenStack backend pool, there is one server from Dell and one server from Cisco. It can create performance issues. So that is one factor. And the second is the most neglected one, is about networking. So we will come to this in detail as well, but we should create both public and cluster networks for production. And public is basically for connectivity with clients. The public network is on which clients connect and interact, and cluster networks are basically for communication internal within the cluster. So let's say we have 5 nodes in the cluster, 3 mon, 3 mgr, and then OSD nodes. So for those nodes communicating within the cluster, that cluster network is used. But you can deploy with one network, and this is what I have deployed, you will see. So you can deploy with one public network only, but obviously not in production. In production, you need to have separate networks for everything. Okay, failure domain is basically any failure that prevents access to one or more OSDs. So let's say your server has 5 disks, and one of the disk fails. So in that case, I mean, that is called the failure domain. So that could be because of any reason. It can be like malfunctioning of daemon. Normally, I mean, this OSD is also backend working as a daemon. So similar to like sometimes HTTP service or Apache service malfunction, and you just need to restart it. Similar to this, it can happen in OSDs as well. So for that reason, you need to plan properly. Like you should not be planning it in a way that if one OSD fails, your whole cluster or your whole application backend stops working. So in terms of saving the cost, it may seem beneficial and it might seem attractive, but in the longer run, when the system goes in production, this can cause issues. So instead of like planning for a failure, you should plan for redundancy and high availability in a way to add extra nodes and storage OSDs in the backend. So CPU hardware considerations, we will also see. These are the factors which we should consider before deploying a cluster. We should consider some factors, and based on that, we can have an overall design and hardware specifications or configurations. So for CPU, Cephmon and MGR nodes don't have like extensive CPU requirements. So a light CPU can work for them, but Ceph OSDs, since they run Rados service in the backend, they make some calculations using Presh algorithm. They need to replicate data. In case of failure, they need to recover and maintain their own cluster map. So for those, they require some high-end CPUs as well. It depends on the overall load of the cluster. So if you have like, let's say 12 OSDs or 16 OSDs, and those are SSDs, and then those are of high storage, let's say 2 TB, then 32 terabyte on one server. So if you are running on that scale, you need to consider a high-end CPU for that. So as I mentioned, requirements vary by use case. A starting point might be 1 core per OSD for some light workloads and 2 cores per OSD for heavy workloads such as RBD volumes. So RBD volumes are same like Rados backend. So these are the block device volumes for the virtual machines. So if you are running for your Ceph storage cluster for these volumes, then you should have some high-end CPU. And similarly, RAM is also like for monitor and manager nodes. Low RAM can also work even for this 64 GB. It can be reduced depending on your load. So if you have, let's say 3 or 5 node cluster, then even 32 GB would work as well. But depending on the overall cluster size, it needs to be up to 128 GB memory of for the monitor and manager as well. So and also one more thing, like once the cluster is up and running, it might not mon and manager even might not require extensive memory. But let's say if there is any failure within the cluster, then they for that period of time during the failure happens, and they need to perform recalculation and moving data between different OSDs. For that period of time, monitor and manager also requires some extra memory as well. So you need to plan accordingly for that. And then for Blue Store caching, they normally if you deploy any Ceph cluster, the default is 4 GB, and it can be changed depending on, let's say, need or the size of OSD. But this consumption can increase during recovery. Let's say one OSD fails, or you are replicating some data, you just change the replication factor of any pool from 2 to 3. So then you need some extra memory for that OSD. So in that case, you need to increase the memory of Blue Store caching. So one more thing is about disk drive. So the disks in this Ceph cluster, RAID should not be used, because since Ceph is also replicating the data in the backend, so there is no point of using the RAID. So you should not be using the RAID in this case in Ceph OSDs. But one more thing is like using a higher size disks to save the cost, because the larger the disk size is, the less will be the per GB cost. So the another important aspect is about network. So if we have let's say 1 TB, if there is a server failure altogether and we have only 1 GB per second network, so it will take to replicate 1 TB between servers around 3 hours, and 10 TB will take 30 hours. So if we have 10 Gbps network, the replication would take 20 minutes and 1 hour respectively. So the networking is very important. Let's say you have a very high end SSD deployed or SSDs installed in the server, but your network is still 1 GB. So you cannot get the optimum or the maximum performance out of those SSDs because the network is also not supporting, because this Ceph storage works on the network side as well. The clients connect it through network, and if the network is slow, then even if the SSDs can provide higher IOPS, then the network would be slow and you cannot achieve the desired IOPS. So normally it's better to have 25 Gbps, but these days 10 Gbps is very common. So at least 10 Gbps is recommended, but it's better to have 25 Gbps for production cluster. For normal testing cluster, for applications for which you don't require much of the high IOPS, you can have 10 Gbps, or even I think in some cases 1 Gbps would be fine as well. It all depends on the application needs. So, and if you need to have some more details on this, you can refer to this link, like talks.ceph.com, and from there you can get the actual hardware recommendations from the Ceph community as well. Okay, this is what I explained on the network part or on a high level. So we have management network. Okay, this is the high level architecture of a Ceph production cluster. So we can have Mon servers, we can have OSD servers, and here what we will do is basically Mon and MGR can run on the single server. It is not a requirement to run Mon and MGR on a separate. We can run, but it's not mandatory. So we will be running Mon and MGR, we can run on the same server, and OSDs should be running separate. And in case of OpenStack, if you have OpenStack controller with enough resources, you can run Mon and MGR on that OpenStack controller as well. So for those who understand this part, like this Mon service and MGR service will be running on OpenStack, and then these OSDs will be connected to that Mon and MGR service. So this one Gbps network, it is for management and provisioning network only. So let's say once you are deploying a Ceph cluster, you can use this 1 Gbps to install the OS on these servers and then configure them with some like cluster configurations. You can use this network. But for the cluster network and public network, once the cluster is deployed and client needs to connect, this one is the client. So client needs to connect, it should connect using at least 10 or 25 Gbps, and similarly there should be a cluster network. So if OSD1 needs to replicate some data to OSD2, it should be going to cluster network to avoid degrading the performance of this public network. So if there is only one network, then OSD1 will be replicating the data to OSD2 using this public network. And imagine if the data amount is high, then it will impact the overall performance of this storage cluster. So that is why it's better to have cluster network separate and public network separate, and then management network to deploy or configure this storage Ceph storage cluster. So any questions till now?
Apparently, there are no questions at this moment. So.
Okay. Okay, then next we will move towards the actual deployment which we have. So I have deployed Ceph on my laptop as well. So these are the specifications of the laptop I have. So Core i7, the laptop has 48 GB RAM and 512 GB SSD. And the OS running on this is, I mean, on my laptop, it's different, but I created a virtual machine in VMware Workstation. So it is Ubuntu 20.04, and then there is virtual bridge network. We will see this in detail. So simply there are 4 servers in total. These are actually a virtual machines: deploy server, server 1, server 2, and server 3. Okay, I will go to that. Just give me a moment. Okay, so is the CLI visible, or should I increase the font size?
Oh, we will need some bigger fonts, yes.
Okay, let me try. Okay, settings. Is it better now?
I'm not sure that we are seeing the entire screen. Yeah, or the terminal. Yeah, okay, that.
Yeah, actually, I just made it small. So I will make it bigger, but I just to make it familiar with this. So we have this deploy server, which is basically this server, and then we have, okay, I will show you Sudo version list. So basically we have these 4 VMs running. I have named client instead of deploy server, and then we have these 3 servers running. So the next thing is basically these are the IPs. I mean, I have deployed using the minimal configuration, and we will see this is also enough for just for the testing purposes. So deploy server is having 2 CPUs, 4 GB, and similarly server 1, 2, 3 are having 2 CPUs, 4 GB memory. And the difference is in deploy and server is basically 1 into 10 GB. Actually, I think it's 20 or 30, but the remaining Ceph OSDs which we are using is for each server, they are connected to 3 into 30 GB of Ceph OSDs, and we will see that. So preparing Ceph deployment. So what I have done is basically, let me see how we can. Okay. First thing is we need to install Ubuntu on all hosts, and then we need to install Ansible on the deployment server. Okay, let's see step by step. Okay, so this one is the deployment server. Okay, I need to increase the font of this. Okay, just give me 1 minute. Okay, and appearance, I will increase the font size to 18, apply. And then we have this. Okay, this one is basically our deploy server, and what I have done here is, I forgot. This one is basically our Ubuntu 20.4 on and similarly on other servers, server 1, 2, and 3. I need to increase again. Sorry. Okay. And similarly, we have Ubuntu 20.04 on other servers as well. And the next thing we need to do is install Ansible on the deployment server, which we already did. Trying to forget the command. Okay, this one Ansible 296. This one is on the deployment server. And the next thing is basically we need to create entries in etc host for all nodes or use DNS server. So these entries are basically required to keep the names. So what I did is basically since Ceph Ansible, and then here I have entered the DNS names for these servers, and why I did it is basically to have these names in the Ansible inventory file, and also to keep the names in the Ceph status and everywhere. So that is why I have mentioned this. I have created this entry in etc hosts. And the next thing is create Ansible user and enable passwordless sudo. Copy SSH keys in all hosts and assign static IP. So these all the points I have already done. Actually, I have already deployed this Ceph cluster. So I'm just repeating the steps here so you guys can understand. I'm not sure why my voice is echoing. I think now it's better. Okay, so once these steps are done, the next thing is we need to clone the repo from this link, git clone https github.com cephansible-git, and this is the, you can say, master branch which contains all these different Ceph versions. So I have deployed this this Ceph version called Pacific and using the stable 6.0, and this actually requires Ansible 2.9, which is by default comes with Ubuntu 20. So this is what I did, and next we will see. Okay, let's see first. Okay, I cloned this branch here. So this is the full branch, and then I checked out, and it contains all these files. And actually, we don't even need to know about all this full directory files. Only 3 or 4 files are needed to edit, and then we can do the actual deployment. So we will see next. Okay, first you need to create an Ansible inventory file for Ceph nodes. So this is the inventory file in which you specify mons, mgr, and OSDs. I have not deployed MDS because it depends on your need. So if you need MDS, just one second. Yes. Oh, sorry for that. Actually, I'm answering the questions on the chat as well. Okay. So Mons, MGR, OSDs, I have not specified MDS because that is needed for the client, and for demo purposes, I'm not using that. But for Mon, MGR, and OSDs, as I said, that for testing cluster, you can deploy all in one server as well. So that is what I did here, because since I'm deploying on the laptop, so that is why I'm using Mon, MGR, OSDs, everything on one server. And this is the inventory file for that. And this host file is deployed here. The next thing is these are the important files now. So there is a file called groupvars all.yml. In that file, you just need to specify these parameters. The other file which comes as a sample, it is quite, I would say, detailed one, which again, those all are not required for, not even for production. There are some limited features you need from this file. So these all are commented normally, but it provides, like, if you need Cephx authentication, in these there are a lot of variables here which you can edit. But what I have done is basically I have created a simple groupvars YAML file. We will specify that we need to download from repo, and which repo. It is a community version. We specify the release specific. Since we already checked out to that branch, so if we specify any other release, it will give an error. It will say that the expected version is specific. And then I have specified here only a public network, since again it is a test network. So that is why I have mentioned only public network here. But if you need to do a production. So you can specify a cluster network here. And then you need to specify this monitor interface on which this should be the one related to the cluster network, and dashboard admin password, Grafana admin password. So these are the password for Ceph dashboard and Grafana admin password. We will see both of those shortly. And then devices we need to specify. So since these are virtual devices, that is why it is showing VDB, VDC. We will see what are the devices on. These are the devices, but we will verify. So you see we have VDB, VDC, and VDD. So you need to specify these devices here in that file to confirm. Let's say if you have maybe 8 devices here, but you don't need all of those to be part of Ceph. So you just need to specify the devices which you want to be part of Ceph as an OSD. Okay, and then this file I will show you again. Okay, not here. Yeah, okay. So this is a simple file and which you can use to deploy this. The next one is site.yml and osds.yml. So these are the 3 files which you need to be worried, or the 4th one is the Ansible inventory. So these are the 3 files: group vars, site.yml, and osds.yml. So these files are already provided as a sample. If you see this, get group var, all we already checked, OSDs. If you see, this one is a very big file, but we will copy. I have actually already copied group var OSDs. And yeah, okay. So you need to specify devices here as well. And there is another option of this auto discovery. Okay, in this OSD auto discovery, if you set it to true, you don't need to specify the devices here, and it will automatically detect all the empty devices which are not partitioned, which are not part of anything. Ceph will automatically detect those devices if this option is true and add them in Ceph cluster. But if you need to specify the specific devices, then you need to set it to false here, and then you can specify the devices. As I mentioned, that if you have multiple devices but you only need few devices to be part of that cluster, so you can specify them here. And this is it, like this is the only parameter you need to configure in osds.yml file. Okay, and the next thing is site.yml. And actually you don't need to edit anything here. It is just you by default what it comes is basically, by default it comes with this file, and you just copy it to site.yml, and that's it. You don't need to edit this file. cp site.yml sample to site.yml, and this in this osd's yml sample you need to edit these. You need to specify the devices. And before we actually start the deployment, you can just like verify the connectivity. We will do that now. Why it's stuck? Okay. Simple mgrs dash module ping. I'm just verifying the connectivity. I'm specifying the host file which I've created in this directory. So if I don't specify, I mean, this is the Ansible thing, but if I don't specify my host file, then it will default to the etc Ansible host file, and which is empty. That is what it's mentioning. So we can verify all these connectivity with the nodes Ansible hosts, or you can specify all module ping dash I hosts. Okay. And after this, you need to run this command Ansible playbook hosts. You need to specify host file and this sites.yml. Actually, if you are familiar with Ansible, so this sites.yml file will be using actually that group vars OSDs and group vars all.yml file. So this using this sites.yml, you will deploy the actual cluster, and we will see our cluster now. Actually, I used it and I already deployed it. And I actually used Ansible user. From root, I can do anything, but I will go back to Ansible. And then we will see status of our Ceph cluster. So you see we have 3 daemons monitor, which are server 1, server 2, and server 3. Age is 9 hours because I recently rebooted them. And then MGR, we have 1 active, which is server 2. And then standbys are server 3 and server 1. And then OSDs, we have 9 OSDs, since we already checked that on each server we have VDB, VDC, VDD, 3 OSD per node, and we have total of 3 servers. So the total becomes 9 OSDs, 8 up. Okay, I think I set one up. Okay, that's good that one of it is down. We will set it back to up. Okay, 9 OSDs, and it is showing 8 are up, 8 are in. Okay, we will see the issue with the 10th one shortly. Okay, since the deployment is done, we can see the status and we can check the server health, each of it. Ceph to Ceph M to health. Okay, so all the servers are in healthy state. That this is what we saw here as well. But there is one OSD which is down, and we will see why it is down. I know I was checking something, so I made it down. I will make it back up in front of you guys. Okay, the next thing is, yeah, okay, CephDF. Okay, so yeah, any questions till now?
I'm just wondering, so these Ansible scripts are only for deployment?
Yes,
or
correct.
can you also deploy or create pools and volumes and what have you?
No, not for volumes or pools.
Right.
Actually, volumes or pools will be created through an application. Let's say we can connect it to OpenStack, and through that we can create some pools. We need to get directly here, and then when we connect it to OpenStack, from there the client request will come and new volumes. Let's say we create volumes on OpenStack, so those will be created here. But pools we need to create manually. But there are scripts to expand, or let's say shrink the volume. So let's say we have 3 OSDs, let's say we have 12 OSDs and we need to reduce them to 9. So there are playbooks to reduce them to 9 OSDs, or even we have playbooks to expand the storage cluster. Let's say we have 3 nodes now, we need to make it 5, so we have playbooks for those as well.
Okay.
Okay, so let's see one command. Okay. So CephDF, if you are familiar with DF only, so it is showing CephDF for Ceph disk free. So we have total of 240 tries available. Used is 0.02, and if you see, there are 2 pools which are created: device health metrics and pool 1, which I created recently. Placement groups I specified for this is 64, and you see maximum available for both is basically for one it is 85, for one it is 128. The reason is basically, if I need to end this slideshow, one moment. Okay, what we can get is sudo ceph get. There is okay. Okay. Ceph OSD get pool, Ceph OSD get OSD pool get pool 1 size I think, yeah. So if you see this one, the pool size is set to 2, and if you see the size of this one is 3. So basically these are the replication factors. The data written in this pool 1 will be replicated twice only, and data replicated to this health matrix pool will be replicated thrice. So that is why it is showing as 85 and 128, and it is showing the full capacity, like not it is not dividing them into each based on the pool. It is showing the total capacity and dividing them based on that.
Right.
Okay. Okay, we were on. Okay. Ceph TF you are already aware, and then let's say if you want to see the cluster map, I think this command is too much detailed to be understood. Okay, so to Ceph OSD pool ls. Okay, this command is basically used for viewing all the pools available or created in this Ceph cluster. So we currently have only 2 pools. So if we move along, actually I will show the slide as well. So Ceph DF is basically just to show the available disk in that cluster or available storage in that cluster. Then we have Ceph OSD Dump, which is basically shows all the information about the OSDs. OSD tree we have not run, but it shows us the OSDs which are available on each node. So if you see this one, so we have Ceph OSD 0, 3, and 6 available on server 1, and you see this one is down. And we will see why it's down, because I made it down earlier. So similarly, we have server 2, 3. So those are the SSDs. Okay, we are on server 1, so we will see the status of Ceph OSD at 0 is down. So you see this one, actually I stopped the service earlier. So this one is down because we stopped the service. So if I start the service, it will become up. So you see this one is down here, and it's down because I stopped the service earlier. Yeah, okay, it's running. So we need to give it some time to understand. Yeah, now it's up, you see. And if we go sudo ceph -s, so we will see 9 OSDs and 9 are up. So, and if we do ceph df, it will show 270 GB. Earlier it was showing 240 GB. Okay, will we connect this cluster with any app? Not now. Okay. Yeah, this one actually and one more thing is, let's say you need to take out one OSD for any reason. So what you can do is basically you can set Ceph OSD out. Let's say use Ceph OSD out 0, 3. Okay, one more thing is these IDs are unique, so for whole cluster, so it will not be like if 0 is available on server 1, so it will be available on the other server. It will not happen like this. So we will specify Ceph OSD out 0 and marked out. So now this OSD is out of cluster and it will not be used. You see this one is also total space is now 240 GB, and this is usually used for maintenance mode. So let's say you want to remove or replace any faulty disk or disk which is causing issues. So you can mark this as the out, and then you can replace, and then what you can do is Ceph OSD in 0. Okay. And then, okay, pool size, we will create some pools now. Okay, Ceph OSD pool create test pool. Okay, this one is the name and this one are the placement groups we specify. Normally those depends on the number of disks. They can be 16, 32, 64, 128. In very rare cases, those will be higher than 128. It depends on the uh, cluster size. Sudo Ceph OSD pool get test size. Okay, so by default, whenever you create a pool, the size is 3. So let's say we have one application for which we don't require any replication. So for that, we can even set the size 1. And by default, this is not allowed. Like Ceph does not allow configuring replication factor to 1. This means that if any OSD goes down, the data will be lost. That is why it is not allowed by default. But if needed, we can do that. Ceph. We need to specify mon allow pool size 1 to true, and then it will ask for 1 on allow. Okay, Ceph mon allow pool size 1 config. Okay. So Ceph config set. I forgot that command completely. Okay, and now it allows. So if we set it to 1 now, it will still say you need to type this. Yes, I really mean it. In some cases, if you delete the pool, it will ask you, yes, I really mean it. So it makes sure that you are not doing something accidentally. Okay, so now it sets the pool size to 1. And I think we are already over time a lot. So I will try to wrap up. Okay, so this one, if you see, this one is showing test pool as maximum space available. So because we set the replication factor to 1 only. Okay, I think we can skip that part, and then yes, I think we can have this command. This command is basically to show the whole configuration of the OSD or performance matrix. So let's run it for one server only. Where is it? Yes, okay. Sudo because of one reason of Ceph dash Rehman because I don't know exactly the Ceph node on this. Yeah, okay. Ceph OSD 0 is sock performance dump pipe. This exactly. Okay, so from there you can see all the performance related metrics here if you need that. So it's showing blue FS, DB total bytes, DB used bytes. So these are the performance related parameters which are available if you need to view them. So we are here till the end. So do you have any questions till now? Any I would say confusions or any, have you got some understanding of how you can deploy that?
Hello, Abdul.
Yeah, hi Nasir.
I have one question.
Yeah.
Can Ceph support the dynamic provisioning?
Sorry, your voice is not clear.
Can Ceph support dynamic provisioning?
Okay, what exactly you mean by dynamic provisioning?
We can provision the storage by two methods. It may be a static and it may be a dynamic. And static, we request for a specific storage
Mm-hmm.
that we need 2 GB or 3 GB, whatever the size is.
Mm-hmm.
In dynamic, it is specially used and nowadays that if the application needs some storage,
Mm-hmm.
they can claim it dynamically. even they can
Okay,
claim.
okay. I understood. I understood your point. So in Ceph FS, based on the configuration, you can do that. But this, I would say, RPD volumes, you need to specify exactly what size should be for that block device volume. So in RBD, you cannot do that, but in Ceph FS, if you configure it correctly, you can do that, as per my understanding, I think.
Is it not supported in RBD? Dynamic
Yeah,
provisioning?
yeah. Actually, to be very honest, I need to check because this use case in RBD, we never came across. Like we have a specific use cases in which we only need to specify the request. Yeah.
We used it dynamic provisioning, and we configured it with Huawei Dorado. Uh,
Mm-hmm.
Therefore, I'm asking that is it supported in Ceph? Because I don't know much about Ceph,
Okay.
and it was
Yeah.
a great session. I really enjoyed it.
Thank you. Thank you. So in terms of dynamic, actually, we never came across this use case, to be very honest. So I have not checked it.
Okay, no problem. Thanks a lot.
Yeah, no worries. Okay. Any other question from someone?
Abdul, next question is
Yeah.
if we deployed a Red Hat OpenStack,
Yeah.
uh, and the Ceph cluster is deployed on Ubuntu,
Mhm.
will we integrate them?
Yes, we can do that, but Red Hat will not provide you support for OpenStack backend issues if you face, because Red Hat, they only support full-fledged solution from Red Hat. But
Have
if,
you configured this?
no, normally we have configured Red Hat OpenStack and Red Hat Ceph.
Red Hat Ceph, yeah, I know
Yeah.
that.
Yeah. So normally we have done that, but this use case in terms of Red Hat with Ceph, Ubuntu Ceph, I don't think anyone could do that as well, because normally if you go with open source, it is fully open source. It is not mix of, like, I mean, Red Hat is also open source, but that is a solution which comes with their own set of defined
Uh,
procedures, like.
Actually, this question rises in my mind due to I have already deployed OpenStack, and
Mhm.
now if in future we want a storage that is we deployed a new Ubuntu, can we integrate them? I was thinking like in this
Yeah,
case.
it will work. It will definitely work. Okay, in test scenarios, I have done that, but not in production.
Yeah. Can we integrate with Juju Charmed OpenStack? Because that are also on Ubuntu.
Yeah, Juju OpenStack with this of Ceph open source. Yes, you can do that. That's absolutely fine.
Okay. Thank you.
Yes. Yeah, no worries, no worries. Okay. And any other questions, Nasir, or anyone else? Okay, in that case, we will move towards the end. You can reach out to me on LinkedIn or my email, and you can also follow this link. This video recording will be uploaded to this YouTube link by tomorrow, so you can also watch this session later on if needed.
Thank you.
And
It
no
was a
worries.
great.
Any feedback you need to provide? Was I
It
going a
was a
bit
great.
fast, like, or it was good for you?
Really, we enjoyed it.
Okay, thank you.
Okay.
And also, I will reach you out personally on email.
Yeah, sure, definitely. Okay then.
Okay. Thank you, Abdul,
Thank you, Gabriel.
for this introduction to the to Ceph and the Ansible deployment method. Appreciate you being with us, and
No
hope
worries.
to see you next time.
Yeah, sure. Thank you, Gabriel. Thank you, everyone.
Thank you.
Thank you.
Bye,
Thank you.
everyone.
Thank you. Bye-bye. Bye.
Bye.